In this video, we'll be determining whether events are independent. Let's take a look at example 1. Determine if events A and B are independent. Notice we're given the probability of A, we're also given the probability of B, and we're given the probability of A and B. We know, based on our formula definition, that two events A and B are independent if and only if the following is true. The probability of A and B is the same as the probability of A times the probability of B. If this holds true, then we can automatically conclude that events A and B are independent. Since we're given the probabilities here, let's go ahead and substitute in. So we have the probability of A and B is 1/8. Notice the probability of A is 1/4. The probability of B is 1/2. Now on the left hand side we have 1/8. That is the same as 1 times 1, which is 1, 4 times 2, which is 8. Notice since 1/8 is the same as 1/8, we have what we refer to as an identity. Therefore, we can conclude that events A and B are independent. And that is because our definition formula has been satisfied. Now let's take a look at another example. Example 2. Determine if events A and B are independent. Again, recall that two events A and B are said to be independent if the following formula holds true. So we have probability of A and B should be the product of the probability of A and the probability of B. Let's go ahead and substitute in what we know. We know the probability of A and B is 3/20, so let's write it down in there. We know the probability of A is 3/5, and we know that the probability of B is 3/10. Now, rewriting things out here, we have 3/20. Let's see if this is the case in this right hand side. So we have 3 times 3 is 9, and 5 times 10 is 50. Now notice, obviously 3/20 is not the same as 9/50, so this is not an identity. The formula for independence is not true, or is not holding true here based on the actual values that were given. Therefore, we can conclude that A and B are not independent events. And when we can say that those events are not independent, we can conclude that they are dependent. Thus, A and B are dependent events. So, given this type of problems, if you're given the probability of an event, the probability of a second event, and the probability of the intersection of those two events, then we can use this formula definition for independence. The probability of A and B should be the same as the product of the probability of A and the probability of B. With that said, this concludes our video. So I wish you the best of luck in your homework. Have a great day.